So, for number 6, identify any discontinuities and where they occur. What you guys should realize with number 6 is that's just a straight line. It's the line y equals 2x, so it's a nice line that kind of goes like this. You go up 2 over 1, up 2 over 1. There's absolutely nothing wrong with this line, and therefore it's going to have no discontinuities. So none is what type of discontinuities that one has. For the next one, nothing cancels. I don't really have anything that I can simplify, but the bottom is going to go to 0. And because that bottom is going to go to 0, this means I'm going to have an infinite discontinuity. To find that, I take the bottom, and I'm going to set that equal to 0. So I'm going to take the square root of both sides, and then add 2. So I have an infinite discontinuity at x equals 2. For number 8, you're dealing with basically the exact same thing. Nothing simplifies, but the bottom can go to 0. So what you need to realize is that that factors into x plus 2 and x minus 2. So that means I actually have 2 infinite discontinuities, and they're in 2 different places. So I have an infinite discontinuity, and when I set this equal to 0, I get negative 2, and when I set that equal to 0, I get 2. So I have infinite discontinuities at negative 2 and 2. Number 9 is a beautiful, wonderful parabola that has absolutely nothing wrong with it, and so therefore there are no discontinuities. Now number 10, on the other hand, you can see that, yes, the bottom is going to go to 0, but is it simplifiable, if that's even a word? Can I simplify this? The top factors. So because what is on the bottom currently is going to cancel, that means I do not have an infinite discontinuity. I have a point discontinuity at the term that factors. So that's going to be x equals negative 3. So I'm going to take x plus 3, set it equal to 0, and that's going to give me my answer. Now number 11, it should say 2 right there. Again, big thing with this is you've got x's in the top and bottom, so my guess is something is going to factor. So if you factor the bottom, you should get x, oh, sorry, this is a plus 2, that's a plus 2. So you should get an x plus 2 and an x minus 5. So those are going to cancel. With that being said, that means I would take the one term that cancels, set it equal to 0, and that's going to leave me with a point discontinuity at x equals negative 2. Now, is there anything else that's left? What you guys should be saying is, yeah, there's something else left in the bottom. So I've got a y equals 1 over x minus 5 left. So not only do I have a point discontinuity, but that makes an infinite discontinuity as well. At, well, where is the bottom equal to 0? X minus 5 is equal to 0 at x equals 5. So I have 2 different types of discontinuities at this point, one at negative 2 and one at 5. Now the thing that you guys need to realize with these point discontinuities is that that's an actual point on the graph. And you can find that. So what you're going to do is plug in that negative 3, in this case, back into what you had left. Well, what I had left was this. So y equals x minus 3, so negative 3 minus 3. That means the point that's missing is the point negative 3 for the x value, negative 6. So this is the point that is missing. That is my point discontinuity. So don't forget that when you do point discontinuity, you don't just say it's at x equals negative 3. You got to go back in and find y. So not only is it going to be x equals negative 2, but I'm gonna plug -2 back into that. And I'm gonna get y equals 1 over -2 minus 5, which is -7. So that's the point -2, -1 over 7. All right, 3 more. For number 12, that's the greatest integer function, so this is going to have a jump discontinuity at every integer because it jumps from one to the next every single time. Let's spell integer here today. So it has a jump discontinuity at every integer. This one, it's that special absolute value, so it's going to have a jump discontinuity at, you can graph it and see it, or it's going to be this value, x equals 1. And the last one is a piecewise. So I'm going to kind of clear this out and shift the page over so we can see that a little better. So piecewise is going to give you another jump discontinuity. And where does the jump happen? It happens at the split in the graph. So that's going to be at x equals 0. So those are how the continuities work. Your homework tonight is a worksheet that's already in the bin over by the window or over by the door. So go ahead and make sure that you pick up a copy of that. And you're welcome to start working on that now if there is time left. I will see you guys on Wednesday. Please make sure you